Then I said, what was the reason of that? The acidity strength of the carboxylic acid is higher than your alcohol. When the carboxylic acid, right, dissolve with water, right? Yes. When your carboxylic acid dissolve in water, react with the water. This is what RC4OH. Reacting with water that able to produce this equilibrium, right? Forming the carboxylate ion, right? Whenever you see, right? So always this is your right side, this is your left side. Always the reaction forward to the right side to forming the H3O plus. Why this is its acid. So it is able to why that's why we are telling you your carboxylic acid is more acidic than the phenol and the. So what is the major reason? Why this reaction shifted towards more right side than the left side? Yes. The formation of the phenoxide ion, the resonance stability of the phenoxide ion comparatively higher when you compare with the alkoxide and the phenoxide ion. Yes, the carboxylic acid, right? When you take the resonance hybridization of the carboxylic acid and the phenoxide ion, you can simply say the phenoxide ion, how I'm comparing the phenoxide ion will show the low charge separation, no charge separation, therefore it moves quick. How I say that, right? Your carboxylate acid able to show. Can you define how this happens? Yes. So initially what happens is this group has moved and this has cleaved and you will end up with what? The positive and the negative charge. So the charge separation is there. Why? It has the positive and the negative charges, so it must stay. When you speak about the carboxylate ion, what is happening here? RCO O minus. So what is the charge separation? It able to produce RCO minus, and this is what? Double bond. How it was happen? Yes, again you can see this is as moved and this has cleaved. Therefore, there is already minus was there. This minus has moved, right? Because of what? It able to form the double bond. The excess one. So can you see the resonance hybridization? He only but the anion. So the charge separation is not there. Therefore, the carboxylate ion is more stable than your carboxylic acid. So if your carboxylic acid is more stable, carboxylate ion is more stable, your reaction always the forward toward the right side of the reaction than the left side of the reaction. Therefore, you will end up with what? The production of the acid is high. There we are telling now the carboxylic acid is more acidity compared to the alcohol and sugar. Are you all clear? Are you all clear? Yes, guys?
Miss,
Yeah.
the first one is
Hmm.
carboxylic acid plus water.
Yes. When the carboxylic acid reacts with the water, it is able to produce what? This is what the carboxylate ion is and the H3O plus. H3O plus like your H plus, that is acid. So we are telling is carboxylic acid more strength of the acidity, right? Because of the production of this H3O plus in aqueous medium. Okay. So why the reaction is a equilibrium means what? This reaction can be either forward or backward. The two things happen. It could be happen in the equal rate. One should be high, one should be low. Right? But they are telling, according to their statement, the forward reaction is a more favorable than the backward reaction. Why it's so? Your phenoxide ion is more stable. The resonance stability is high than your carboxylic acid. That's why your reaction is forward reaction is more favorable. So this is means what the acidity of the carboxylic acid is high. Is it clear? This is another way of explanation. Is it clear?
I was thinking that
Hmm.
the carboxylic acid
This one, this area,
up.
this.
One section was ketone and other section was alcohol.
What is ketone? What is alcohol? Oh my
No,
god,
miss.
this is H3O plus acid. This is your
No,
carboxylate ion.
no, miss, not there, miss. First itself. I was thinking like that.
This is you thought ketone and alcohol.
No, up. You put a green tick mark.
Yeah.
One section was ketone and other section was alcohol.
How can you think like that? This is carboxylic acid, right? RCOOH, right? You
Yeah,
thought like your ketone and alcohol. My goodness. This is the structure of the carboxylic acid. Don't confuse.
okay, now.
Yes, Zain, what about you? You can use the chat box then. If you could not
Yeah,
speak,
yeah,
it's clear. Study,
yeah.
study. Okay, sometimes they will ask such. I don't know whether I asked. I already prepared the paper. I couldn't remember. But sometimes they used to ask why the acidity strength of the carboxylic acid is higher than other phenol and everything. You able to explain this statement like this by using the charge separation, the resonance stabilization, the forward reaction. The forward reaction, you can say the right side of the production of the acid H3O plus is more favor than the production of what the carboxylic acid backward. Why we are telling is the stability of the carboxylate ion is high than the stability of the carboxylic acid. The production of the carboxylate ion is more favor. That's why your reaction more forward toward the right side of the reaction. Okay, right? Again, a recall. Okay, we spoke about what the carboxylic acid and when the aqueous medium is able to show this such kind of the yes, I already said about the reaction mechanism. It's at the equilibrium. We said it's always shifted more towards the right side to attain the equilibrium. Why it's so? Yeah, the carboxylate ion, the relatively stable One, stabilization. The resonance stabilization of the carboxylate ion is higher than your carboxylic acid compared to your phenoxide and the alkoxide also. So this is what the stabilization of this. So by using this, you can compare with your phenoxide ion and the carboxylate ion. This is what your carboxylate ion able to show the stabilization. Therefore, there is no charge separation. This is what we are talking here. Here is a charge separation is there. There is no charge separation. Therefore, the stability of the carboxylate ion is high than the stable resonance structure of the carboxylic acid. So this is what is the reason the acidity strength of the carboxylic acid is high. Right. Now we are going to speak about what the reaction involving the cleavage of the CO bond. Okay. What is the time now? Today we are having class at up to 1:30, right? Usually you all not having Thursday. Okay, right. Okay, so we have studied up to now the cleavage of the OH bond. It's finished. Now I am going to speak about what? The cleavage of CO bond. Like your aldehyde and ketone. So what kind of the reaction that we have? The first reaction is the reaction with PCl3 and PCl5. So first, the carboxylic acid. Can you say OH? Right. These both are carboxylic acid. Yes, guys. Are both shows the carboxylic acid for structure, or one is can you define?
Download is carboxylic acid.
Hmm. So what about the up one?
That is then the carboxylic acid.
R can be alkyl or aryl. Right. Aryl means what? Having the benzene group, aromatic one. Alkyl means what? Having the CH3 group. So these both are carboxylic acid. Are you all clear?
Yeah.
Okay. Right? Thank you. So now the reaction with yes, the reaction with PCl5 and PCl3. We'll do this as PCl3. What should be the answer? Any guess? Yes. Any guess? What is this? We have studied this functional group. What kind of the functional group is this?
Alkyl halide.
Alkyl.
Wait. Yes.
Acid chlorides, carboxylic acid chlorides, right? We have studied the COCl is we are speaking about what? Acid chlorides, right? Whenever your carboxylic acid reacting with PCl3 or PCl5, it will end up with carboxylic acid chloride. Are you all clear? When this is react with PCl5, you will have, seems to be similar, CH3, CO, it will substitute by Cl. And here you have the PCl3 and down this is the PCl5. So other products are different. Here you will end up with what? The phosphoric acid, H3PO2. But when you have the PCl5, you will end up with the POCl3 along with HCl. The product is very important. Do the conversion, only the major part is here. This major part is here. These are the rest part. So are you all clear? Are you all clear?
Okay.
Okay. This is what it's showing you. Right? The carboxylic acid react with the PCl3 and the PCl5. Sorry, it should be small. Giving the carboxylic acid chloride. And you can see the COOH, PCl3, which is end up with what? COCl and HCl. And when you have, I said, right, though it is a alkyl or aryl group, doesn't matter, both are the carboxylic acid. It will end up with the carboxylic acid chlorides, right? So it's a kind of the acid derivatives, right? So when it's react with the PCl5, it will end up with what? Again the acid chloride, but this is PCl5, the PCl3. This is what we studied under what the aldehyde ketones. The same product, the phosphoric acid here, the POCO3 and the HCl, hydrochloric acid also will be there when you have the PCl5. The sub one is different, but this is what is the important area. These are the main products. This is what we are expecting. Are you all clear? So next one we are going to speak about the reaction with the carboxylic acid reacts with alcohol in the presence of the acid catalyst to give the ester. So what it is telling is, when a carboxylic acid, right, react with alcohol, right, they are telling in the presence of the acid catalyst. So what is the acid catalyst that we are using here? In presence of the acid catalyst, it will give the esters. What is that? Oh, sorry. Acid catalyst is found sulfuric acid. And you will end up with ester with water. This is the common reaction. What is the ester? What is the structure of this? Yes, CO. We say this is R. Again O. R. This is the structure. We are going to speak about the acid derivatives tomorrow, not today. Okay, carboxylic acid derivatives. There we are going to speak about what? Esters, amides, acid chlorides. We studied, right? Okay. According to that, okay, you're able to know when it reacts with the alcohol, the carboxylic acid, in the presence of the acid catalyst, it will end up with what? The ester. So you can see here. Let's say write the example. You are the person going to write the answer, right? CH3 COOH reacting with alcohol C2H5OH, right? In presence of this acid chloride, H2SO with heat. Can anyone write the answer here? It's going to form what the ester. Please write the answer. Think and write. Yes. Anyone? Okay, ester is right. I need a structure. Okay, ester plus water. Okay. I want structure. Draw the structure. I don't know how to draw the structure. Hmm? Structure. Draw the structure. Why question mark? Yeah, Shahid. Right. So look at here. Your carboxylic acid. This is your part of the carboxylic acid. Can you see? RCOOR. One is your part of the carboxylic acid, and rest part is your part of the alcohol. Yes. Okay. Yes. So we'll draw this part. Water should be there now, so one should lose the OH, one should lose the H. This is what you have to understand. We need to remove the water. Okay. So if you want to remove the water, the OH from here, hydrogen from here should be removed. Now can you write? Now? Yes, definitely you all can. Yes, let's be right. The CH3, CO, finish. And again, oxygen, C3. It's right. Esther, is it clear? Is it clear?
Okay.
Okay, this is how you have to. Actually, when you look like that, it seems to be like what? Nucleophilic substitution reaction. Your ester, this group, like what? This group is like a nucleophile. It is substituting, and this is as it is. Actually, that is not happening here. This is what the nucleophilic addition reaction. This is very important. This reaction is not a nucleophile substitution reaction, not a nucleophilic substitution. It is the nucleophilic addition reaction. How could you? Though you end up with trigonal planar shape of the molecule. Earlier also trigonal planar. Your final answer is a trigonal planar, but your intermediate is tetrahedron. So there was an addition, then only the rearrangement has occurred. This you can be understood by writing the reaction mechanism. So this reaction is not a nucleophilic substitution. This is the nucleophilic addition reaction. So what is happening? Let me write the nucleophilic addition reaction. The reaction is there. First we write the reaction here. I'll just write them here. So what is happening? Yes. NCH3 C double OH reacting with C2H5OH in presence of what? Sulfuric acid, concrete, or sulfuric acid, presence of heat. You will end up with ester CH3CO OC2H5 plus H2O. I'm going to write the reaction mechanism. The first step is the CH3 COOH reacting with C2H5OH. They said that is the catalyst, acid catalyst we are using. Why? To boost up your reaction. This acid is not taking part in your reaction. So first it will form the tetrahedral intermediate. How? So you can see the OH, the hydrogen. This hydrogen will substitute here. Already another OH group is here, right? And this O C2H5 is there, CH3 there. Are you all clear? Is it clear? Again I'm telling you, right? Again. Okay. Look at your carboxylic acid. This is alcohol, right? This is your carboxylic acid. This is your alcohol. Your carboxylic acid hydrogen part will attach with your this oxygen, right? Why the movement of this cleavage of this, your mechanism for step is like that. They will form the OH group, right? And now you have the OCE2H5, and this is able to form what? The tetrahedral. This is OH from the alcohol, and this whole part from the alcohol. Are you all clear? Are you all clear? Right? By using this acidic catalyst, what will be happen? This structure will lose, right? Yes. This is able to form what? By loses the water, able to form the ester. How? Again I said, yes, it able to lose the hydrogen here. Okay, the OH here. This OH and the hydrogen will be gone. Okay, I will use another one. This OH, sorry, this hydrogen and this OH will be removed. Now you will end up the answer is now CH2. With water. Is it clear? Is it clear, guys? Somewhat okay, no? Huh? Okay, right again I'll recall. Fine, okay, we'll clear this one. Oh, again it's going to finish. Right? So what is happening here? I said when the carboxylic acid react with your alcohol in presence of the acid catalyst, it will end up with what? The esters with water. So as we have, you can see like a nucleophilic substitution reaction, but this is not a nucleophilic substitution reaction. This is a nucleophilic addition reaction. Why I said this is as a nucleophilic addition reaction, they are able to form the tetrahedral intermediate. So this is what is happening by looking this reaction mechanism. So when you see the reaction mechanism, here your carboxylic acid it's reacting with what? The alcohol forming the tetrahedral. So this is your alcohol and this H is your alcohol, right? Later the dehydration because of what this is loses because of this catalyst acid, you will end up with the ester by removing these two OH and this hydrogen. You will end up with this answer. This OH, this hydrogen and this OH. Are you all clear? Hmm? Is it clear? Okay, right? Shall I move for the next slide? Then I can finish within 8 minutes this class. Is it okay? Shall I move?
Okay.
So next we are going to speak about the reduction of the carboxylic acid with lithium aluminium hydride, lithium AlH4. So here what is happening? Right. The carboxylic acid, right, reacting with lithium aluminium hydride, lithium AlH4, in presence of the water H plus H2O. It will reduce as, it's a reduction reaction as alcohol. Very important thing is the lithium aluminium hydride is very powerful reducing agent. Here we are using only for the carboxylic acid, we are using only the lithium aluminium hydride, not the sodium borohydride. This is what the least powerful reducing agent. So we are not using this is with carboxylic acid. Earlier aldehyde ketone we use both, right? But the lithium here carboxylic acid you can use only the lithium aluminium hydride. Are you clear? Are you clear? Yes. So simply what is happening here is the CH3, CH2, COOH. Your reaction is using what? Yes, lithium aluminium hydride in presence of acidic medium water. You will end up with alcohol. Alcohol how? This will reduce as a CH2. That's all. So you can write this is as a CH3, CH2. Right, right like that, and use another color. This CO reduce as a CH2 again. CH2OH. Is it clear? Can you write the answer for this reaction? Your benzene, okay, COH, same reagent. I'm not using. Right. Can you write the answer? So I can finish the class. Quickly. 5 minutes more. Once it's finished, you all can leave, guys. Inshallah, tomorrow we will have the class at 12. Fine. Yes. Quickly, write the answer. Yes, anyone? Shaheen, you want try? Again, I said your R group should be there, right? Your Cu will reduce as a CH2. Another part will be there. That's all. That's all. Are you clear? Hmm?
Yeah, Miss.
So this is what, guys. Here we are speaking about what the carboxylic acid react with the lithium aluminium hydride, which is a powerful reducing agent to give the alcohol. Note, this carboxylic acid is not using their carboxylic acid and their derivatives never is reduced by the sodium borohydride. Why? That is the less powerful reducing agent than your lithium aluminium hydride. So therefore, this is your reaction. Okay. Are you all clear? Again, I just recall it, right? Okay, look at here. Your CO group will reduce as a CH2. That's all. Here your CO group reduce as a CH2. That's all. You have to understand. This is what we are saying, the reduction reaction. Your carboxylic acid reduce as a alcohol. Okay? Clear? Yes, guys, clear? Okay, we have complete the carboxylic acid. Tomorrow we will start the reaction of carboxylic acid derivatives. Right. So here we are going to study one by one. Acid chloride, amide, esters and everything. Inshallah. Okay guys. See you tomorrow. You can leave. Assalamualaikum warahmatullahi wabarakatuh. Okay guys. Bye.
Miss, class finished?
Yeah. I will take one
Ah.
half an hour. Maybe tomorrow I will take, or the day after tomorrow I will extend it. So next week I will take little bit higher for the revision. So I think tomorrow or day after tomorrow we can finish the carboxylic acid. We have less another 10 minutes or something. It's okay. Okay, happy?
Miss, home is very cool.
Uh-huh.